Do you feel the vibes?
So in the different areas where we do see data represented, there is always a reason behind it. There's always a motive. There is always some sort of point the presenter is trying to make. And that could be in, presenting political data. It could be in presenting, just basic surveys of people and so on. So depending on all of that, depending on the context and the purpose and the, what it is that you're trying to show, you can represent the same set of data in different ways. So that's what we're going to talk about today. One of those ways is a frequency table, which uses tally marks to record and display frequencies of events. You've been doing this since you were in elementary school. Remember in elementary school, they would give you projects and be like, go and ask your classmates what flavor ice cream they like, right? And you're like, 3 people said chocolate, 1, right? That's what you did. So here, there is some sort of sport, and I don't know, do people play the sport? Do they like the sport? Do they hate the sport? I don't know, but whatever it is, 15 people chose basketball, 25 football, and so on. And so you tally by 5s. You all know how to do this. Okay. A bar graph compares categories of data with bars representing the frequencies. So it's the same thing. Here you have a frequency table. You can get the exact same information, and now you can create a bar graph out of it. This too shows the frequencies, and we have the frequencies here in this case, right? These frequencies are over there, and then you've got your what are these categories here. Notice in a bar graph, the bars are separate from each other. They are not touching. Okay, there is empty space in between them. A histogram is it's a type of bar graph used to display numerical data that have been organized into equal intervals. The thing with histograms is they do look different from a bar graph because the bars are all touching. So why don't we create a histogram to display this data? So here we have the type of music and the frequency. The frequency will go here. So this is the result of a student survey on favorite music. Here you can either write frequency or you can say number of students. Okay. And now look at this. The numbers go from 13 to 32. So, I've kind of divided it here. Maybe it's best to go up by tens. So this will be 0, 10, 20, 30, 40. Okay. And now we have how many? We have 4 categories. So I'm just going to divide this into, 4 categories or 4 regions. Let me see if I could do it equally. All right. Okay, so the first is country, hip hop, metal, and rock. That's where I would go, FYI, the last column right there. Yep. Really, I know, surprising. I used to be, yep. Okay. Rock, alternative. Me in a band? Oh, no. No, that would be the last piece of music ever played. Okay, so country, 13 people. So we're, somewhere over here. And then hip hop, how many do we have? Okay, so here's how I do this. Okay, so hip hop here, how many? Right at 35. So I basically, what I do is from here and down, I just draw a straight line. You see that? And then from here down, I draw a straight line. Okay. So then I have metal at 20. and then rock at 32. Here. You don't have to shade them, but do you see how all of the bars are touching? Oh, and here we have to put a title as well. So I'll just put like music or types of music. Usually, okay, so I will do like the horizontal lines, and then I'll just get a ruler and do vertical from the highest to the bottom. In a histogram, the bars must be touching. You can't have empty space in between. You can't have gaps in between them. Okay, because it later goes into something else. Yeah.
So for Instagram, so it's the same thing as a bar graph, just their question.
Correct. The table shows the ages of volunteers in an animal shelter. Make a histogram of the frequencies. So again, here we have volunteers, right? So this is the number of volunteers. And then here we have ages. And how many categories do we have now? 1, 2, 3, 4, 5. So I'm going to split this into 5. Like this. All right. And the frequency, let's see, it goes from 0 to 12. So maybe I could go up by 3s. Now, for the ages, first I have 16 to 25. If it doesn't fit, we can tilt like this. 26 to 35. And so on. When you're doing a histogram, right, and it's numerical categories like this, like for the ages have to be separated into equal increments. So for example, 16 to 25, that's how many? It's actually, if you count the 16, it's actually 10, right? So 10, 10, 10, 10, 10, right? Okay. So here we go. So in the first case, we have 6. And then I have, how many? 4. 9. Okay, see, these have to be touching like this. And then what else do we have? 12. So that goes all the way up. And how many? 8. Right. Okay. Another way to represent data is by using a line graph. A line graph, we use a line graph to show how data changes over a period of time, right? So sales at Marshall High School store are shown in the table. Make a line graph of the data. All right, so here, let's see, I have September to May. So these are months. Okay. And so the first one here, on the y-axis, that's September. And then I have October, November, December, and so on until May. Oh, March. And here I have sales. Okay, what is the highest and lowest that I have here? It looks like 198 is the lowest. Oh, 168 is the lowest. And then 670, that's the highest, yeah? Okay, so maybe we could just go up by hundreds, right? So 100, 200, 300, 400. Okay, and yeah, so if we had a grid behind it, if I should have put a grid, it would have been easier to do these points, but it's okay, we'll manage. So September, I had 670 here. October, 229. And again, you're going to estimate a little bit, right? So if it's 229, it's between the, like it's in the first half and so on. November, 300. Is that right there? December, 168. Oh my gosh. Okay, January, 290. February, how much? Oh, 388. Lots of people bought stuff in February. And then March, 412. April, 309. And May, how many? 198. Okay, so we can, in a line graph, obviously connect these with a 9. And, you know, feel free to make them like jagged edges. They're not going to be a smooth, continuous curve because it's discrete, like distinct points that you're connecting. Okay? Questions? So you can see a trend, right? So this is good to use if you have a change over time. Okay, next we're going to talk about a stem and leaf plot. How many of you guys have seen this before? We're all, yeah, it's a very elementary, middle school thing, okay? So you have the digits of the least value from the which form the leaves, and then the rest of the digits form the stems. So the speeds of, in mile per hour, 20 of the fastest land animals are listed below. Use the data to make a stem and leaf plot. Okay, so we start with the lowest values, right, by tens. So we have numbers in the 30s, 40s, 50s, 60s, and so on, right? So in the 30s, what do we have? We have a 32. How many of those do we have? 2 of them. So you say 3, 2, 2. 2 32s, right? And then what's the next one in the 30s? You have to go in order. 35. How many of those do I have? 1, 2, 3. 5, 5, 5. And then there is 136. Right? Yeah? So I have a 32, a 32, a 35, a 35, and so on. Yes, the stem is the 30s, and then the leaves are all the ones digits. Okay, so then how many do I have in the 40s? I have, 4 40s. So a 4 and then 4 zeros. I have a 42, it seems. Right? What else do I have? 143? How many 45? And a 48. Right? And this is my way of organizing, right? If I circle or like, cross off, then I know which ones I've used. What else do we have? 50s. I just have 3 50s. So 5. And then I have 61. And I have a 70. Right? Okay. So how is this useful? Like you could see how many you have in each. Like you can see a good distribution, right? How many you have in each, like, tens place. Okay. All right. A circle graph is a graph that shows relationships between parts and a whole. All right. So if you have to show that, then you use a circle graph. So take a look. The table shows how Lily spent, not you, 8 hours of one day at summer camp, right? So parts of a whole day. That's when we make a circle graph. All right. So for this, we want to put them in percentages, right? So I have 3 hours, 1, 2, 2, a total of how many hours? 8 hours. So each one of these, okay, so I have 3 over 8. That's 37.5%. 1 over 8, 12.5%. 2/8, that's a quarter, right? When you do that, it's kind of easier to do. Okay, so these two are a quarter, they make up a half. So why don't I split it into a half? And then another half. And where you put these, it really doesn't matter. So basically, she spent a quarter of her time eating and another quarter hiking. Then it's 37.5 and 12.5. So how much is 12.5? It's a half of a half, right? So it's like half of that quarter. So I can, eyeball it that way. Spend that much time doing crafts, and then the rest of the time doing canoeing. Okay? Yeah. Question? Wait, start again. Do whatever you want. Yeah. However you want it, do it. This is easier for me because I have less things to split into. Listen, I'm not going to take a like a protractor and see if this is exactly like this many percent, right? But just whatever works for you. Okay? All right. Okay, next we have a box and whisker plot or a box plot, huh? Have you guys seen that before? Box and whisker plot? Yeah, so I know Portola did it in their algebra 1.
Archer does it in 8th grade.
Huh?
Archer does it in 8th grade.
Yeah. Yeah. Okay, so here we go. Okay, so a box and whisker. Describe how the outlier affects the quartile points. Okay, so here's what we're going to do. First, sort it. So we have an 8, 13, 14, 2 16s, 2 18s, 2 20s, a 22, and a 30. Okay, so let's see if there's an outlier. All right, before we do that, basically this is the min, max. Where is Q2, the median? The first 18. Where is Q1? The 14. And Q3 is the 20. Okay. The interquartile range is 20 minus 14, which is 6. 1.5 times 6 is 9. So 14 minus 9 is 5. 20 plus 9 is 29. Are there any outliers? It has to be less than 5 or greater than 30. Greater than 29. So 30 is an outlier. Okay. So we come over here. All right. I have the minimum 8. Now the 30 is an outlier. If the 30 is an outlier, I put it there. The new maximum becomes the 22. Okay? The new maximum is the 22. I put a point there. Now, I'm going to put 3 more points at Q1, Q2, Q3. What's Q1? 14. Oh, actually no. We have new Q1 and Q2s, don't we? What's the new Q1 and Q2 now? If I just have these, what's the new quarter 2? Second quartile? 17. And the new quarter Q1? Oh. So it'll still be the 14, right? Sorry. Oh my ear. Okay, so if it's 17, it's still the 14, and then here, the 20. Okay, so at 17, at 14, and then at 20. Okay, now, this is Q1, Q2, Q3. Here, I make a box like this with another vertical line in the middle. You see where the box of the box and whisker plot comes in? Now, you draw whiskers from here to the edges. Okay? The outlier is the outlier because it stays alone. It's literally a loner. All these are one bunch. The box, it just goes from, it's the interquartile range basically. It goes from Q1 to Q3 with a, what do you call it, line in the middle for Q1. Okay, so that's the box and whiskers. Okay. So how did the outlier affect the quartile points? What did it do? It changed which one? It changed the median, right? It brought the median over one. Okay, so now we talked about all these different types of graphs. So let's take a look at this and say, in these situations, which would be a better one to use? So the results of women's Olympic high jump event from 1972 to 2008. So something that's over time, what would we use? A line graph. The percent of students in a class who have 0, 1, 2, or more than 3 pets. If it's the percent, a circle graph. All right, and that's where we're going to stop today. And there is a worksheet for this as well.
Press start.